Let us take the next molecule, N2. So N2 is having total number of electrons 14. Molecular orbital electronic configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, sigma 2pz2. So the total is equals to 14 electrons over, and it is a diamagnetic. Bond order, half of bonding electrons minus anti-bonding electrons. So bonding electrons 2, 4, 6, 8. Anti-bonding electrons only 2 are there. So that it is 6 by 2 equals to 3. There is a triple bond between the two nitrogen atoms in the N2 molecule. 12th one. Let us take N2 plus ion. So N2 plus means N2 molecule lost 1 electron, so that out of 14, now 13 electrons are present. So molecular orbital electronic configuration, everything not necessary to write down. We have to remove 1 electron from here. Remaining everything is same. So that I am writing from here sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, and sigma 2pz1. Since 1 electron is present, it is paramagnetic. Bond order, half of. See, 1 bonding electron was removed. Anti-bonding electrons, no change. So that we can write down the 7 minus 2. 5 by 2 equals to 2.5. Is the bond order in N2 plus molecular ion. Next, 13. N2 minus. N2 minus means extra electron we have to add, so that it is equals to total number of electrons 15 electrons. So now molecular orbital electronic configuration, it follows the more than 14 electrons series. So that I will write down the complete electronic configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1 equals to pi star 2py0. So that 1, 2, 3, 4, 5, 6, 7. 7 to the 14 plus 1. 15 electrons are there. Here 1 electron is present. So it is a paramagnetic. Then bond order is equals to half of the bonding electrons. Now let us cancel these two. 2, 4, 6, 8. Anti-bonding electrons 3 are there. It is 2.5. Now let us make a series. Orders between the N2, N2 plus and N2 minus. So comparison. Of N2 comma N2 plus comma N2 minus. First of all, bond order comparison. Highest bond order is with N2 molecule, so that we can write down that N2 is greater than. These two are having the same bond order, so that we can write down that N2 plus equals to N2 minus. Bond length. Lower the bond order, higher the bond length. then these two must have the equal bond length. But between these two, wherever less number of anti-bonding electrons are there, that is more stable. That means having the lower bond length. More the anti-bonding electrons, higher the bond length. So that here 3 anti-bonding electrons are there. Here 2 anti-bonding electrons are there. So that bond length is more for N2 minus, next N2 plus, next N2. Bond enthalpy. So bond dissociation enthalpy depends on the bond order. Higher the bond order, more the bond dissociation enthalpy. So that N2 has the highest bond dissociation enthalpy. Next one, N2 plus, N2 minus. More stable is N2 plus because less number of anti-bonding molecular orbital electrons are there, and here more electrons in the anti-bonding molecular orbital. So that N2 is greater than N2 plus, greater than the N2 minus. So this is the order. Now let us see the oxygen molecule. O2 molecule, total number of electrons, 16 electrons are present. Molecular orbital electronic configuration, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 equals to pi 2py2, pi star 2px1 equals to pi star 2py1. So that it is equal to 16 electrons, 2, 4, 6, 8, 10 plus 4, 14, 15 and 16 electrons. See here it is having the unpaired electrons in the pi star anti-bonding molecular orbitals. That's why it is paramagnetic. So this theory is able to explain the paramagnetic behavior of the oxygen molecule, because it says that the presence of unpaired electrons in the pi star orbitals gives the paramagnetic nature to the O2 molecule. Other theories do not explain the paramagnetic nature of the O2 molecule. It is paramagnetic. Bond order equals to half of bonding electrons, 2, 4, 6, 8. Anti-bonding electrons 2 plus 2, 4. That means there is a double bond between 2 oxygen atoms in O2 molecule. O2 plus. From this you have to remove the 1 electron, so that it is equals to 15 electrons. So final electronic configuration is, here only I am writing, rest everything is same. Pi star 2px1 is equals to pi star 2py0, because 1 electron was removed. And here also, this is also paramagnetic in nature. Now bond order equals to half of bonding electrons not disturbed, 8. Anti-bonding electron 1 reduced, because 1 lost, 2.5. Bond order is increased, 15. O2 2 plus. That means from here we have to remove the 2 more electrons. So total number of electrons equals to 14 electrons. And molecular orbital electronic configuration, straight away, since from here to here 2 electrons are removed, those 2 electrons are from these pi star orbitals only. So that finally pi star orbitals are with pi star 2px0, pi star 2py0. Since no electrons here, remaining electrons are paired electrons, so it is a diamagnetic. Bond order, half of bonding electrons again not changed, 8, minus Earlier 4 antibonding electrons, now 2 more removed. That means only 2 antibonding electrons are present. 6 by 2 equals to 3. So there is a triple bond in the O2 2 plus, similar to the nitrogen molecule. O2 minus. O2 minus means for this 16 we need to add one more electron. That equals to total number of electrons are 17 electrons. So what could be the molecular orbital electronic configuration? Since I am not repeating the common things up to here, everything is similar. Only last electrons I am writing. So that here 16 electrons means these two are common. One more electron means extra electron we have to add here. Pi star 2px2 equals to pi star 2py1. Unpaired electron is present, so it is a paramagnetic. Bond order, half of. Bonding electrons again no change, 8. Anti-bonding electron 1 extra added. That means instead of the 4 we have to take the 5. So this is equals to 8 minus 5, 3 by 2 equals to 1.5. Now let us see the O2 2 minus. This is called the peroxide ion. And this one called as the superoxide ion. So peroxide ion means extra 2 more electrons. Means in addition to the 16 electrons, we need to add the 2 more electrons. So it becomes totally 18 electrons are present. And molecular orbital electronic configuration, that last electrons, add 1 electron here, 1 electron here. So that becomes pi star 2px2 equals to pi star 2py2. So all are paired electrons. So that's why it is a diamagnetic. And what could be the bond order? Bond order equals to half of bonding electrons, again no change, 8 electrons, but anti-bonding electrons here 4 are there. In addition to that 2 more electrons are added here, so it becomes 6. So that says a single bond. Now if you observe one thing in comparison to all these, here anti-bonding electrons 4, anti-bonding electrons 3. One anti-bonding electron if reduced, bond order increased by 0.5. From here to here anti-bonding electrons 4, anti-bonding electrons 2. Means 2 anti-bonding electrons are removed. That's why for every 1 electron bond order, for every removal of the anti-bonding molecular electron, bond order increases by 0.5. So here we remove the 2 electrons. That's why 2 into 0.5 means 1. Plus in addition to the two bonds. That's why here we got the 3 bonds. And what if you add the 1 anti-bonding electron? When you add the 1 anti-bonding electron, bond order decreases by 0.5. Here 4, here 5, here 2 is the bond order, here 1.5. Means 1 extra anti-bonding electron decreases the bond order by 0.5. And from here to here 4 anti-bonding electrons, here 6 anti-bonding electrons. For every 1 electron 0.5, so that 2 electrons means 1 bond order reduced. That's why 2 becomes 1 in this case. So it clearly says that the presence of the number of bonding electrons increase the stability and bond order, and the presence of the anti-bonding molecular orbital electrons decrease the both bond order as well as the stability. Usually bond order is directly proportional to the stability. Let us take those orders also. Comparison. Comparison of O2, O2 plus, O2 2 plus, O2 minus, O2 2 minus. So first let us take the bond order. Highest bond order is with this one, O2 2 plus, 3 bond order. Greater than. Next, O2 plus 2.5. Next O2, 2 is the bond order. Next O2 minus 1.5. Last is O2 2 minus 1. Bond length. Higher the bond order, lower the bond length. So that bond length is least for the O2 2 plus, O2 plus, O2, O2 minus, O2 2 minus. Bond order is directly proportional to the stability also. Means stability order also follows the similar order. So this is about the comparison of the O2 plus, O2 and its respective ions.